Okay, on the second part of the video, we want to look at the steps to finding variance and standard deviation. So we're going to write down the steps first, and then we'll go through an example. All right, so the steps to finding variance and standard deviation. The first thing that we would do is to find the mean of our data set. So that means that we're finding the mean. Whether it's population mean or sample mean, it doesn't really matter. You're just finding the mean of whatever the data set is. The second thing that you would do is to find the deviation of each value from the mean. And that means that you're going to do the data value x minus the mean. The third thing that you're going to do is you're going to square each of those deviations that you found. So that means that we're going to take that value where we did the data value minus the mean, and we square it. The fourth step is to find the sum of all the deviations. Now, the sigma symbol is what we use to represent the sum. So that part of the formula looks like that, where we are summing up all those deviations squared. The fifth step is to divide that sum that we got in step 4 by the number of data values minus 1. So we're taking and dividing this answer from step 4 by n minus 1, which is the number of values minus 1. Now, of course, if we're doing population, it would just be the number of values, not subtracting 1. And so that gives us this formula. X minus the mean squared divided by n minus 1. And then, of course, our last step is, if we're at step 5, that is actually, that answer is representing the variance. So when we get to step 5, that result is what the variance is. And when we get to step 6, that result will be the standard deviation. And what we will do on that step is to take the square root. And we're going to take the square root of that result that we had in step 5. And so that's how we end up with our formula, completing that process step by step. Now, let's run through an example. So we have a data set 1, 2, 8, 11, and 13. Now, what will make this whole process very easy is to make a little chart. So we're going to make a column for X. And so we're going to list our data items 1, 2, 8, 11, and 13. So we list those values in our chart. Then the next column will be X minus the mean. Now before we can put our answer there, of course we have to actually find what the mean is. So we add up all the values, divide by 5, and we find that our mean for this set of data is 7. And so we use that. So we do 1 minus 7 is going to give us -6. And then we do 2 minus 7 is going to give us -5. And then we do 8 minus 7 is going to give us 1. 11 minus 7 is going to give us 4. 13 minus 7 is going to give us 6. Now, if we totaled these answers in that particular column, we would get 0. And we would get 0 no matter what the data was. Every time we did that column, we would get 0. That happens every time. And so for that reason, that's why someone developed this squaring part of the problem to help us be able to calculate without getting the 0. So our third column is where we're going to square the answers that we just got. So -6 squared is going to be 36. -5 squared is going to be 25. 1 squared is 1. 4 squared is 16. 6 squared is going to be 36. And we're going to have to add up this column, which is going to be 114. Now, we're ready to utilize our formula. We have done step 1, the mean, step 2, the deviation, step 3, we've squared them, step 4, we've added up that column. So we're at step 5, where we're going to take this sum and divide by the number of items that we have minus 1. So we have 1, 2, 3, 4, 5 items. And so 114 divided by 5 minus 1 is going to be 114 divided by 4. And this is going to give us our variance. So the variance is going to be 114 divided by 4, which is going to be 28.5. So that gives us that amount. And then we're ready for step 6, which is our standard deviation, which is S, which means we take the square root of 28.5, and that gives us the value of 5.34. And so there is an example for how to have the steps and then utilize them in a chart to help us find variance and standard deviation. I want to point out to you that there is another formula that you can use for standard deviation. We're not going to use it in this particular class. You might see it if you take a further or more advanced stat class, but it's not something that we're going to use. Some people consider it a little easier, but you also have to know a little bit more about statistics in order to understand that particular formula. So we're just not going to cover it in this particular class.